Welcome to everybody to today's DeCarbCH Lunch Talk. Very happy to welcome today Rusbeh Rezania. He works actually at Wien Energie. And his background is energy and economics. We found it extremely interesting to have a look at our eastern neighbor. I think it can be extremely interesting to learn from what is being done in Wien Energie. Especially the topic of his talk is, of course, the decarbonization of the heating and cooling system of Vienna, which is exactly what we're also doing at DeCarbCH. And with this, I would like to give the word to our speaker today.
Thank you very much. Thank you for the invitation, and thank you that I can be here within your lunch time. The topic of today, my presentation goes to the decarbonization of the heat supply in Vienna, and more precisely, I am going to the district heating system. I work for Wien Energie in a department which is called Decarbonisation heat generation. Our purpose is here to get more renewable energy system or more renewable energy production into the district heating system. And we are a small group, which includes 13 people. And from the first concept of a power plant or of a heat plant generation unit to the commissioning of the power plant is our workflow. And after the commissioning of a plant, we gave it to the operation unit, and the operation unit can deal with the plant in the next decades and in the next years. That means our focus is really in the department building a concept, and from concept to the realization of the heat generation units. In my presentation, I will go really in a brief, give you a brief introduction. What is Wien Energie? What we are doing in the company, and I would go to the energy consumption level in Austria and in Vienna. And based on that, we are going to the district heating system. And at the end or in the next part of the presentation, I would come up with some examples how we can really decarbonize the generation part of the district heating system. What is Wien Energie? Wien Energie is one of the is a locally is a multi-utility company. We are producing electricity, heat, and cooling. And also selling gas to our end consumers. The number of employees is in the range of 2,200 people. And of course, we are working in different kind of energy sectors. We have a district cooling system in Vienna. We are also working in the mobility sector with the installation of the electric charging station in the whole area of the city. And in the power production, in the electricity production, we are focusing solar power installation in Vienna and also in the whole country. Okay. And if I go to the more detail to what we are planning in the next few years is a huge investment in the heating sector, in the decentralized heating system, and also in the district heating system. We are focusing, as I told you, the photovoltaic implementation in Austria with the capacity. Our target is to get a capacity of 600 megawatts until 2030. The topic of the cooling and the problems in the summer times is also an aspect of in our strategies, and we want to have a higher production rate of the cooling in Vienna. We have already a cooling network, and we want to increase them. And of course, in one of our biggest strategic points is the integration of geothermal energy in our district heating system. The middle target is getting a capacity of 100 to 120 megawatt until 2030 in the district heating system in Wien. Good. That was only a brief introduction of our company. If I go to the final energy consumption in Austria, the figure goes to the year 2019. in the final consumption, energy consumption in Austria is in the range of 335 terawatt hours, which is subdivided into the electricity, heating and cooling sector, and of course the mobility sector. And what we can recognize here is the heating and cooling sector is the major part of the builds up the major part of end energy consumption in Austria, and this is also the same figure in other European countries. But if we look at the renewable energy share, it is really interesting that we have in Austria, in the electricity sector, a high range of renewable energy capacities or installed capacity is, and the renewable energy share is in the range of 75%. That is because of our hydro power plants, which have been installed after the in the last decades. The renewable energy share in the heating and cooling sector is in the range of 34%, and the lowest part of the renewable energy is in the sector mobility. And the figure only shows you if we want to get an energy transition, we need to first of all the heating and cooling transition, then we need the mobility transition. At the end is the electricity transition. Generally, from the politician aspects or from the discussion, based on the discussion of the decision makers, we are talking more or less in the society in the country, for example, also in Austria, more about electricity transition. And if you show, based on this figure, if we want to get a decarbonized energy system, heating and cooling system must be at the first position if we want to change something. Good. That is the build of the final energy consumption in Austria. And if I go to the district heating system, on the left side, what you see is the energy flow chart of Vienna from 2020. And we have here the district heating system with the heat consumption of about 6 terawatt hours per year. And if I go back to from the conversion factor to the sources, what we can recognize here that the main part of the heat production in district heating system in Vienna is based on using gas. And that is a huge problem what we have. This is not only the problem what we see after the beginning of the war in Europe. We had also some problems in the beginning of 2010s decade from the economical point of view, and that was the reason what we said, okay, we have to go away, or we have to reduce the share of natural gas in our production mixture. But on the right hand side, you see some characteristic factors for regarding to our district heating system. As I told you, the produced heat is in the range of 5 to 6 terawatt hours per year. The installed capacity is more than 2,600 megawatts, and the renewable share is really low. We are at the maximum. We have a renewable share of 18% only in our district heating system. And this is one of the biggest district heating systems in Europe, which we can supply more than 400,000 end consumers with the heat. And the heat production is currently based on two main technologies. One is the CHP, that is the heat, which are based on using of natural gas. We have three big stations or power plant stations, which is in Vienna. And also we are using to cover our base load in the district heating system, we're using waste treatment plants. And we have also 3 of them in Vienna, which build up as a capacity of in the range of 250 megawatts. And with them we can cover our base load in the district heating system. Good. We have a district heating system which is mainly based on gas, and we want to change the system. And if you want to change the system, it is not only to get a diversification in the generation infrastructure, We have also a need of digitalization. That means there is a need of getting current information from the end consumer to the central to the central station where can from there we can also change the output of the power stations. And also what we need is the energy efficiency. That means we have to optimize our end consumer regarding to the usage of the heat level what we have here in our system. With the slide, I want to say, okay, we have to go to the decarbonization. We want to reduce the gas factor in our district heating system, but that is not only done with changing the generation units. It is also a need of the digitalization, and also, of course, very important, the energy efficiency. We need lower temperature level in our system to getting more renewable energy or alternative energy sources in the district heating system. What we have done last year or for two years ago was we had a study, and we asked the question, okay, how can we get to a more decarbonized district heating system? And what you see here is in the right hand side in the graphic, in the current situation, we have a high range of gas power plants in our production. The share of the heat from gas power plants or CHPs will be reduced until 2040. And what we see here is that the share of geothermal energy and the share of heat pumps, that means usage of waste heat, will be increased. And that is the future what we see here in our district heating system. More or less, CHP will be a part of the production side, but not in a lower range. And the more part of the energy production will become from geothermal energy and also large heat pumps. Good. That's the future what we see. And if I want to go to the future, I need to know, okay, how can I get there? And the basic of them is to categorize my alternative sources and to know how much potential do I have, how many potential do I have, and how can integrate them in my system. And what we have done is we categorized our possibilities in three sectors. First is the usage of the wastewater as a source, using geothermal energy for heat production, and also using the waste heat from the industry. For example, we can use data centers or cooling centrals to take their waste heat and put them into the district heating system. Good. That is the basic what we have done in the last years. And what you see here is now a picture of the district heating system in Vienna, which is subdivided in the primary district heating system, that are the red lines, and the secondary district heating system, that are the blue lines in the system. The red lines, that means the primary district heating system, is characterized by a high temperature, up to 150 degrees, depends on the outdoor temperature. And the secondary district heating system are the low temperature system of us. The maximum temperature is here 90 degrees, and also depending on the outdoor temperature. Yeah, that means we subdivided our district heating system in two main parts. And what you see here, the points what are on the plans, goes to our alternative usage, what we have done or what we have realized in the last few years. We have, for example, a heat pump which we are using the waste heat from data center to get it the waste heat in the district heating system. We are planning in our waste incineration plant large heat pump using the condensate as a heat source. We have also a cooling center called Unocity, where we use the waste heat from the cooling. we have one of our first large heat pump, which is located in a power station. I will come to more details to the project, and also we are currently in the realization of the using the heat from the sewage water from the wastewater in the sewage treatment plant in Vienna. And that is an overview regarding to our plans, which has been realized in the last few years regarding to utilization of waste heat. And I go now to some specific project and to show you what we have done in each of the projects. For example, I choose here the large heat pump at Simmering Power Station. We have in the Simmering Power Station 2 CHP units with approximately 1 gigawatt installed thermal power. And the system is so that we are using a cooling water system to cool the CHPs, which are located in Simmering. And we installed a heat pump to use the waste heat in the cooling system and use the waste in the cooling system for the district heating. That means we have a cooling system which has a temperature in the range of 6 and 28 degrees. We take the waste heat from the cooling system and put it in the district heating system with a temperature level at 95 degrees. That is a power plant. That is a heat pump with an installed capacity of 27 megawatts, and the commissioning of the project was in the year of 2019. Another example is using a data center, because a data center provides waste heat and need cooling energy 24/7. And what we do here is we install here a large heat pump with a capacity of 3 megawatts. Using the waste heat, put it to the district heating system, and also we can cover the energy from a hospital directly. And on the other side, we gave the data center a cooling energy, and that is a perfect example for a really efficient system. We can using waste heat, and we can use the waste heat and produce heat and the cooling in the same time, and that is one of our project and where we are using the waste heat from the data center. Our flagship, our biggest project is currently using the waste heat from sewage water. We have in Vienna one treatment plant that is so-called EBS-Kläranlage. The whole wastewater goes to the treatment plant, and after the cleaning, the cleaned wastewater goes to the Danube. And we are talking here about 4,000 to 6,000 liters per second of wastewater which goes to the Danube. And here we use the large heat pumps, using the electricity for the large heat pumps from a nearby hydro power station, and put the heat and the electricity which is used for the higher getting the higher temperature, and put the heat into the district heating system, and the level of the inlet temperature is in the range of 90 degrees. What we see here is we are currently in the realization phase, and we want to get the capacity of 55 megawatts until end of the year. And in the second stage, we will double the capacity up to 110 megawatts. I have here two pictures for you. What we see here on the right-hand side is a picture of one large heat pump. And we will install 3 of them until the end of the year here in the project. And on the left-hand side, you see the whole the building of which has been also completed in the last few months. And currently, we are installing the heat pumps and also the periphery systems. And with them we can put the waste heat from the wastewater into the district heating system. As I showed you, that's what there are 3 examples using waste heat from wastewater or from industry with different kind of properties in the availability, in the capacity, and also in the temperature level. And that is one of our major strategy pathways to decarbonize the heat production in district heating system. And the other one is the geothermal energy. We are when we are talking about the geothermal energy, we are talking about the heat which is stored in the earth. The origin is from earth core, and in the Central Europe, more or less we are saying, okay, the temperature increases by 3 degrees per 100 meters depth. That means if you want to get 100 degree temperature, you need goes down to the deepness of 3,000 meters. What are the best aspects of geothermal energy? This is locally available. This is a renewable energy, and in our opinion, that would be a price-stable technology which we can integrate into district heating system. And with the geothermal energy, we can produce heat. Also, you can produce electricity. You can use it for the cooling aspect, and also you can use it for the storage aspects. And if I talk about the geothermal energy, our focus is deep geothermal energy, and we are focusing on the hydrothermal energy. That means we take the formation water, which is warm, to the surface. We use the heat from the formation water and put it into the district heating system. And the colder formation water goes again down into the deepness and into the same reservoir. That is the potential part of in Austria. What you see here is the red areas depicts the potential area of hydrothermal geothermal energy. What we can recognize here in Vienna, in the surrounding area, we see a potential area, but we don't. You can't see any thermal usage of deep geothermal energy, and that is again our point. We have in the underground the sources, we have on the surface the district heating system, and what we want to try is to put them together. That means we get the potential to the district heating system, and we can get a decarbonization in our district heating system. And what you see here is that we are talking about a huge amount of the potential in regarding to the hydrothermal energy in Vienna basin, up to 400-500 megawatt, what we can see and what we can use for the district heating system. Only again, what we need is specific comprehensive research for that. And in the geothermal area, what we every time need is a good databases. And therefore we set a comprehensive research project from the beginning of 2016, and we with the main aspect to getting in the exploration and to getting more data and information from the underground. That means we had 3 phases in our research program. In the phase 1 and in the phase 1 and 2, we made some acquisition. In the phase 3, we made 3D seismic measurements. We went to the potential analysis. In the phase 3, we close up the research part with a testing in an old borehole, and to get some more evidence regarding the existing of warm water in the underground in Vienna. And with the ending of the research project, we are now in the implementation phase. When I go to the more precisely to the milestones, we had in 2015 a potential study, and we begin then after that with our research project, so-called GeoTIF Wien, and then made some measurements, 2D seismic measurements, a small one, and a big seismic measurements in the 3D seismic measurements in the years 2018 and 2019. In 2020, we get exact information about our target, about our target in the underground, and in 2021 we made a test to getting the information, or to getting the info, or to have more detailed information from the underground. And we made a test in our old borehole and put we get hot water from the underground, and that was the point for us. Okay, in the underground of Vienna we had warm water, and we will go to the implementation phase and to plan next specific plans in regarding to the geothermal energy. And now we are in the planning of the first geothermal plant in Vienna, with a capacity of 20 megawatts, with a output temperature of 100 degrees. And we hope with them we can cover heat supply of 20,000 households. And that is the beginning of the way to integrate more geothermal energy in our district heating system. Our midterm goal is to get 120 megawatt at with the 2030. And in our opinion, we have done everything what we have to do in the research part, and now we are going in the implementation. And this project would be the first project in area of the geothermal energy. Yeah, that is my last slide. As I told you, in my opinion, is the energy transition goes only with the heating and cooling transition. It has to be at the first stage. District heating system has only a future if we meet the challenges of the decarbonization. If we go to the decarbonization, and as I told you, decarbonization is not only the changing of the production infrastructure, but it takes time. If you go to the project from the concept to the commissioning of the project, it takes 5 to 7 years, and yeah. And our midterm strategy is of course to getting the 120 megawatt heat from the geothermal energy for the district heating system in Vienna.
Thank you very much. Thank you really very much, Rusbeh, for this excellent overview.